All right, in this lesson, I'm going to introduce the astype method, which allows us to convert the data types of a series from one to another. And the reason I held off on introducing this method is because it requires a series to not have any null values. So we're going to have to perform some operations to deal with the null values in our data sets in certain columns before we can proceed with the actual code in this lesson. So I'm going to go ahead and re-execute our code to import our CSV. And I'm also going to show the last couple rows of the data frame so that we can see that the very last row still has that entire row of null values. To remedy that, I'm going to call the drop_na method, and I'm going to give it an argument of all for the how parameter. And in this case, we don't even need to do the in-place parameter because this thing is going to execute by itself and give us the data frame with that last row of null values removed. And that's going to be the thing that's assigned to NBA in the first place. So if I execute this, you can see that I have my last row at the very end with all those nulls removed. And now, as you may recall, I also have null values in my salary and college columns. So let's fill the salary values with the zeros. So I'm going to do NBA salary, select that column, fill the empty null cells with a value of 0, make sure that's in place so that it's overwritten, and also extract the college series, fill those NAs with the word none, make that true. Let's preview the first 6 rows. This is all stuff from the previous lesson, so that's why I'm rushing through it a bit. Here we see we now have removed the nulls from the bottom of the data set, that complete row, and we've also taken care of the nulls within our college and salary columns. Now there's 2 ways that we can find out about the current data types of our data frame. We can first use the dtypes attribute, nba.dtypes, and that's going to tell us that we have only objects and floats. As a reminder, object is just Panda's internal syntax for a string, and floats is where I also mentioned an important caveat, which is that in our original CSV, all of these numeric columns are actually stored as integers. And when Pandas imports them and sees these null cells, it has to convert the column to floats. That's just something technical it has to do on the back end to store it. So because we had that last row where we had all of those null values across the board, every single one of our numeric columns was imported as a float. So now let's go ahead and convert those numeric columns back to integers. Before I do that, though, I want to demonstrate the other way that we can get the data types in addition to the dtypes attribute. You may recall the info method, which requires parentheses. And the benefit here is that it's actually going to give us a count of the data types as well as tell us if there's any null missing values in any one of the columns. Since we've replaced all of our nulls with either none or 0, you can see that now all of these columns, all of these series have the exact same number of valid values. We can also see at the very bottom the total memory usage. And many times when you're converting from a more complex data type like floats to integers, you can actually see a memory decrease because it's easier to store an integer, which is a whole number, than it is to store a float, which also includes that fractional decimal component. So I'm going to actually re-execute this info method as we proceed, just so we can see whether this has a impact on our data and our memory usage. And I'll show you as we use a couple of other different types of data types, we'll see how the memory usage is affected. So let's begin by extracting our salary column. It's still a float even though we filled in the null values with 0, and that's because the data type of our column doesn't change just because we filled in the values. So now I'm going to call the astype method directly on the series. And what the astype method accepts or expects as an argument is the new data type that we want to convert it to. So now we have a column of floats. Let's say we want to convert it to integers. The syntax for an integer is int. So I'm going to write that within double quotes. Now, sometimes syntactically, this method does allow you to get away with writing the data type without quotes because it's really like an object behind the scenes. But I always play it safe and just write the new data type in quotes. So we're going to take the salary column values, which are floats, we're going to convert them to integers. Let's take a look. There we have it. We've converted that series from floats to integers. Now, unfortunately, astype does not have a in-place parameter, so I'm actually going to have to reassign this back to our salary series. So again, this occurs first. We get a brand new series of integers, and we're going to reassign it to our salary series, which already exists. So it's going to overwrite it. So now our salary series is integers. We can preview it with the head method, and there we see we've replaced the floats with integers. Now let's re-execute this cell above. We are at 35.7. Let's see if that decreased it. Still 35.7, so no visible impact. That could happen sometimes. Let's practice again. Let's convert our age and number columns into integers as well. They're all floats. So once again, we begin by selecting the column or the series. There we have our floating points. We call the astype method. We give it the int, and then we execute. We see that it looks how we want it to look. We reassign it back. Same thing with, let's say, age. We currently have age, and we want to represent it as a int. Again, there we have it. Reassign that back to age. And now we have those two columns with integer values. To do that in reverse, we're not going to save this, but in case you ever want to convert from an integer to a float, for example, here's our age column, and it's just been converted to integers. It's the exact same operation. We're just going to call the astype method and give it an argument of float, and that's going to convert the integer values to floating point values. And then you just reassign back to the column to overwrite, just like in the previous example. But we're not going to need to do that. And there's one additional one. In addition to floats and integers, I want to introduce a new data type called a category. And this is something that's unique to pandas. It doesn't exist in Python. So a category is a data type that's really ideal when you have a small number of unique values in a data frame. So if you can imagine a data frame of, let's say, employees, and it has 1,000,000 rows, and there's a gender column where you only have 2 possible values, male or female. Or maybe you have 1,000,000 rows and you have a month column, and it only has 12 possible values, 12 different unique things, but they're all duplicated throughout those 1,000,000 rows. Whenever you have a small number of unique values, the category data type can help you severely reduce the memory usage. What it does is, rather than use a string to store a unique string in every single cell, it points every cell that has the exact same value to a single object. So if we look at something like this data frame, we have our position column, and that only has 5 unique NBA positions. I can prove this, by the way, by getting our position series and then using the n unique attribute on it. Actually, it's a method, so we're going to have to place the parentheses at the end. So we have 5 unique values within the position column out of a total of something like 450 rows. That's a very small percentage, so that's the ideal column that we would want to turn into a category. So we don't have to store 450 different unique strings. Instead, we're only going to have 5 objects, 1 for each type of position, and every time we run into identical values like PG or SG, it's just going to point to that same thing in memory. So the way I do that is by extracting my position column, and I do astype, and I do category. We're not going to see any difference, but if I reassign back to position, it's now a category. And now I'm going to scroll back up to that info method and re-execute it. We're currently at 35.7 kilobytes, so after the conversions of the floats to the integers and the categories, we can now see that the memory usage has decreased to 32. Now that may not seem like a lot, but when you think about 3 over 35, we're talking about something like an 8% increase. And let me show you one more example. The team is another great column that we can use as a category because there's only 30 unique teams in the NBA. So if I call the nUnique method, we can see that there are 30 unique teams in this 450 row data frame. That's still a relatively low percentage, so I think it's a perfect example that we can use as our category. So once again, I'm going to call the astype method and provide it an argument of category in double quotes. That's going to convert the values to categories, 30 unique categories. I'm going to reassign that back to team. It's not going to look any different when we look at it on the front end. If we just do nba.head, we can see that the team column remains exactly the same, as does the position column. But now if I re-execute that info cell up here, we can see that the memory usage will go down to 29. And that's pretty significant because we've reduced it from 35 to 29, which is 6 over 35. So that's basically something like a 16 to 20% increase, or decrease rather, in memory. So increase in speed or decrease in memory, really the same thing. So the category column data type is really something to watch out for whenever you have a lot of duplicate values within a column. And rather than store them as strings, you can store them as categories. Just to accelerate the speed and decrease a little bit of the load that Pandas has to take on. So that's the astype method that we can call on the series within a data frame.